Alright, so today we'll check this over here. This is your molecular ionic net ionic worksheet from lesson 4, okay, that you should have done. So check these over off the team. Yeah, I changed number 3 there, but we'll talk about that in a second. Basically, number 3, wherever you see S2 minus, you're going to put carbonate, and it should work out to be basically the same thing, except with carbonate there. Okay? Oh boy. Oh. Okay. So there's the first 3 there, I guess. You need to make sure that when you check these over, please, make sure you have exactly what's up there. I'll get out of your way here. But make sure you have exactly what's up there. Okay. If you need extra help with this, I can. There's tons of questions I can give you. I can give you any question basically on any single and double replacement reaction. I can make those up pretty quick. So if you want more practice with this, by all means, come and see me, and I'll give you more practice with this. You do, like I said, there's going to be 3 questions probably on the test, probably on the final for sure, that will apply to something along this line here. What is the ionic equation? What is the net ionic equation? What is the spectator ion or ions? Okay, and remember, in single replacement you get 1 spectator ion, and in double replacement you get 2, right? So once again, if you want any practice with that, by all means come see me. But those are the answers there for that. Okay. Yeah, I did. For number 3, I said turn sulfide into carbonate. The only difference here is anywhere you see S2 minus, you're going to have CO32 minus. That's the only difference. It works out exactly the same. Okay. All right. So there's some of it there. I'll move it up here right away. So here's 4, 5, 6. Okay, the rest of those there. I thought I'd broadcast the answers for a change because there's people in Mexico, okay, that need to apparently check their answers over. And there's people in Fort McMurray. Seriously, Fort McMurray? Hey, who wants to go there? Hey? Gee. Let's go to Fort McMurray. Okay. Why don't we? Or, hey, let's go to Mexico. Huh? Mexico. Hey, always. Or Dominican. Ooh. Hawaii. No. Alright. We got the hula girls there. Nope. Fort McMurray has a McDonald's. Oil. They got oil there. Yeah. Oil or hula girls? Not really an option, eh? Huh? No. Fort McMurray. Seriously, eh? Fort Mac. Fort Mac. Apparently they have a nice arena there, though. Nice curling place, actually, now that I'm talking about that. Nice curling place there. Hockey rink. Because they got tons of money there. It's all oil. They could bring hula girls there. Now I think about it, they have enough money, probably. Makes sense. All right. All right, any questions? We're good? Yeah? Moving on? Yes? No? Like I said, if you haven't done any of those, I suggest now that you've copied down the answers or whatever, go back and try these on your own, see if you can kind of get stuff to match up there and see how that goes. And if you want extra practice questions, let me know, and I'll get you some of those too. No worries. Okay, and honestly, if you guys can do probably number, I would say 6 is a gooder. 6 and, I don't know. 6 and probably, let's say, 1, I would say you're probably good. Single and double replacement reaction, you should be able to do both of those. Okay, we'll probably have a quiz, but I don't know, maybe Friday-ish on that. Probably, I think, right before the break. That'd be nice. That'd be awesome. And a Monday, probably when you get back from the break, we'll have another quiz. It'll be awesome. You guys got 2 weeks to study. What else are you going to do? Seriously, you're in grade 11. You're not going anywhere. Hey? The people who left have left already. They went to Fort Mac and Hawaii and Mexico. Huh? Yeah, that's right, nothing. All right. Next, questions from yesterday. Let's get those out. Whatchamacallit there? Mass stoichiometry, lesson 6. Lesson 6. Oh. Well, that's actually not the one I was thinking. Oh, yeah, that is the one I'm thinking. Okay, relax. Hey, easy. Lesson 6. Now, I don't have those on here, but you guys have the answers there for lesson 6 there, mass stoichiometry questions. There was 3 main questions, 1, 2, 3, and then there was A, B, C parts to each one of those. Okay? It looked, well, I don't think I have it here actually, but any questions from that sheet with lesson 6 there? Any questions that you want to go over? Okay. So, number 3, from mass stoichiometry questions here. Write a balanced chemical equation for the reaction between zinc and silver nitrate. So, zinc and silver nitrate. Silver is obviously a 1 plus, nitrate's a 1 minus. We're going to get silver, solid, and zinc nitrate, aqueous. Balancing, let's see, 2, 2. Okay, which one out of there, Stephen? All of them. Well, let's do one, and then you should be able to do the rest. Pick one, A, B, or C. Huh? Sure, B. What mass of silver can be produced? What mass of silver can be produced by the reaction when 40 grams of zinc is completely reacted? So basically, if I take 40 grams of zinc, how much silver can I make from that? Well, molar mass, 65.41 grams per mole. We're going to find N here. I got to grab a calculator. Let's see. 40 divided by 65.41 is 0.611 moles. We're going to move that over to here. Remember, in front of here is a 1, of course. It's a 1 to 2 ratio there. So times it by 2. So let's see, times 2-ish, we get about 1.22. I just said 2. Belly. Mass, what's the mass of silver? Somebody, anyone? Somebody? Huh? 107.7? 87 grams per mole. And we multiply those 2 bad boys there. And we get 131.9 grams, and we'll use significant digits, so 3 in the question. So let's go to 132, I guess, all said and done, and hopefully that's the answer. Oh, yay, I got it right. How about that? Yeah. Okay. Remember, the numbers out front have nothing to do with the molar mass. They are how you get from here to here, of course. Okay, so 1 to 2. When I take the molar mass here, the molar mass is just of the silver, right? Not the 2 in front. That has nothing to do with that. That's how I got over there. I multiplied the moles by that. Okay? Good. Any other questions from that sheet? Yes, no? Maybe so? So? I don't know. How are we doing? Those all rhyme. Any other questions? Questions? Anybody else? Questions? We're all good? Make sure you can get those answers, of course. If not, you know, once again, you have to make sure you get the right balanced chemical equation to start here. If you don't, it's going to be kind of tricky, all right? As Run DMC would say. It's tricky. It's tricky. To rock a rhyme that's right on time. It's tricky. Tricky. It's their song, right? Katie knows it. Questions? Anyone? Yes? No? Okay. No? Okay. Today, let's see here. There is one question I'll talk about real quickly here. I'm going to give you another worksheet on some mass stoichiometry here. I was going to move on today, but then I decided that maybe you just need a little more practice. This one's going to be basically, well, yeah, anyway. If, by the way, this is, in case you're at home today, this is lesson 6B. You'll have to get that off the website, people. That's my website, if in case, yeah, practice. It's called lesson 6B. Question number 3 will say something like this. You take a piece of zinc and you put it into some kind of solution here. I actually forget what kind of solution that is. And you get your reactants there. This is question number 3 that you're going to see today. I'm going to give you the sheet right away here. It says that they put 50 grams of zinc in this solution. So they started with 50 grams. Okay. And then they said they just threw in a chunk of 50 grams of zinc. And what we're going to talk about tomorrow is something called limiting reactants and basically which one runs out first, et cetera, et cetera. We'll do that tomorrow, so hopefully you're here tomorrow. But 50 grams of zinc. And then it says when the reaction's completed, so in other words, when this reaction stops and everything is changed, you know, into different products here, you still have 38.5 grams of zinc left over. Okay? So how many grams of zinc actually was used in this reaction? So this question's a little bit different than the rest, okay? And I know that, but this is a good question as well. So we have to think about this. If you just took a chunk of 50 grams of zinc and threw it in this solution, okay, and it reacts for a while, let's say you leave it for a day and it's done reacting, and then you take out that chunk of zinc and it still weighs 38.5 grams, well, how many grams of zinc was used? 11.5 grams was reacted, okay? And of course, that's what I need to use for this question because I need to know how much zinc reacted, right? So that one's just a little bit different than the rest, okay? So that's something to keep in mind. And the second thing to keep in mind is this. When you get to questions that, let's say, when you get to questions that have this plus this, ionic compounds, let's say double here, because it is double replacement, and you get this and this, and you might say, gee, I can't find the solubility of this one here, for example. I can't find that one. In that case there, okay, because we do use different ionic compounds, they're not always on the back of the periodic table for the solubility chart. And you have to look them up, of course, aqueous, solid, right? You might not be able to find that one, but you guaranteed will find this one. So you can find this one. And if this one is aqueous, then I guess this one by default would be probably a solid, okay? Because double replacement reactions very, 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 very often, like 99% of the time, give you a solid there, okay? And if they're talking about a massive precipitate, well, if this is the aqueous one, well, it's not that one, so it's got to be this one, okay? And this would be your precipitate here then. All right, so just kind of keep that in mind when you're doing questions as well. If you don't know, can't find one of them, then you got to look at the other one, decide on that, and then the other one would be the opposite, of course. All right, I think that's pretty much it. Yeah. So lesson 6B. On the website there, or this one here. This one here, for some reason, I don't know why, but I haven't changed it. This one's called, well, mass stoichiometry as well. And it says lesson 9 on here for some reason, because I haven't changed it. Well, I know why, because I haven't changed it. But please cross out lesson 9 here, it says at the top, and change it to 6B. Okay? Lesson 9, I had to rearrange some stuff here, and I didn't rearrange it very well. Okay? So, if you go to the, this is for the people at home, if you go to the website, you'll find all the lessons and all the worksheets there as well, and this is lesson 6B. And the first question is, a solution of lead-2 nitrate is mixed with excess potassium bromide, so any lead nitrate in the solution will react. So that you should be able to find. In fact, maybe I can do this. Let's see here. Where am I here? Let's see here. On the main page. Where am I here? There we go. Yep. Sure. You're going to grab one over there. Okay, so that's the worksheet we're working on today. Well, I did change it there, 6B. I don't know what happened there. Okay.